Hello everyone, this is Dr. Ali, and in this session we want to start working with Reworks World. We want to familiarize ourselves with those functions and whatever this come with this interface. For a start, you need to go and select your language. For here in these sessions, we want to just use Python programming language. And then there are some keyboards functionality that are provided for us. So if you click on this Reworks keyboard, there are some functions like move, turn left, take, and so on. For a while, we only use move and turn left. There are different challenges that later on I will solve that we might use different functions, but here we just focus on move and turn left. And there are also some conditions like add goal and clear and so on that we don't need it for this session. So for example, if you want to just move the robot in the direction of the face, in the direction that the face of robot is, for example, here, the robot face is toward right. So if I just want to go one step forward, I just need to go and say move. Right. So if I run this, see the robot goes one step. So if I want a robot goes one step up, first I need to change the direction of the robot's face toward up, and then call this move function. So what I mean is if I say turn left and then move, the robot ends up here. First went up. So for honestly, by knowing this move and turn left, we can do a lot. For example, for this session, I want to solve this challenge that we want the robot to start from the position 1 and 1 and follow this green path and end up all the way on the top left, the row 10 and column 1. Or because in the Python, we start the indexes from 0, so we could say started from index 0, 0 and end up row 9 and column 0. So for being able to do this challenge, we first need to break this down to see how can we attack this problem. First, if you notice, whenever the robot is in the actually even rows, those rows that has even index, for example, 0 is an even number, 2 is an even number, and so on. For all of those even rows, the robot face is toward right, and for those odd indexes, those rows that have odd indices, the robot face is toward the left, that I showed them with the brown arrow. So this is the first one. The second thing that we need to figure out is how can this robot, when let's say the robot starts from here and follow this blue arrow and comes here and reach to this point. Now we need to turn right and follow this brown arrow. And the same here, turn right, follow the blue arrow, and here turn left, again turn right, and so on. So we need to figure out how to do this turn left, turn right. So that's very simple actually. If the robot is here, all of these turn left, I show them with the red arrows. That basically what's happening is first, if the robot is here, for example, we need to change the face of the robot toward up. Because remember, when the robot reach here, its face is toward right, toward this direction. So first we need to change its face toward up, means that we need to call this turn left function. Then robot needs to move one step up. That's why I put move here. And then robot faces also need to turn left again because it want to pass this direction toward left. So that's taking care of the turning point of all of these right side of the this wall. Similar thing for the green arrows. Robot, when you reach this point, need to turn right and just follow these blue arrows. So how it can turn right? Very similar. First, we want to change the face of the robot toward up, because again, robot face is toward left when it reaches here. So first we change the face of it toward up, then move one step, and then turn right again, change the face of the direction, face of the robot toward right, and then we can move. So, but the thing is, we don't, this turn right function is not defined. It's not defined by Reboot, but we only have move and turn left. So that's why I define this turn right function separately and use the three turn left, because if you can evaluate this yourself, but whenever, it doesn't matter which direction the robot is, if you call 3 times turn left, its face it become toward the right side of the robot. You can check this, it's very simple, you can check it yourself. So then yeah, so now that we know all the pieces, just we need to start coding it. Let's see how can we um, code this that I explained. So let me get rid of this. First, I said we need to define a function turn right. In this turn right, we need to call 3 times turn left. And then I want to define a turn right modify. Turn right. We need to call this turn right function that we develop, and then move one step to the top and turn right. And then we need to define turn left modify. For turn left, we need to call turn left, then move up, then turn left again. All right. So these three functions will take care of those green and red arrows that I explained. Now we need to traverse all the rows that we have. How many rows we have here? 10 rows. So we need a iteration, or we need a for loop in order to go to each row one by one. So I can say for I, or let's call it for row in range 10, if row modulo 2 equals 0. There's in this if statement, we want to check if we are in the even row or we are in the odd row, because as I explained, I'm using different logics for each row. If you are going toward right, we are following the blue and red arrows, and if we go toward left, I'm following the brown and green. So here I simply can say, so if we are in this direction, we need to, how many times we need to times we need to move? 9 times. So I can say for call stands for column in range 9. Just we need to call this move function, right? And then when the move finish, when we move 9 times, it means we move from here to here. So we are at the most right possible cell that we could reach. Now we need to turn left. So we already developed this turn left modifier. So we need to use that. So we can say turn left M. And then similarly, if you are in the there is one. So for again call in range 9, move, and similar to previous explanation here, when the robot reaches here on the far left, we need to turn right. We already developed turn right modify, so let's use that. Turn right down. But the problem, there is a small issue here. When the robot at the last row reaches to the far left, means that when the robot reaches in this cell, we shouldn't call this turn right anymore, because if we call that, it goes beyond the, it hit this wall and we will fail the game. So when we reach here for the last row, we just need to stop here. We don't need to turn anymore. So for doing that, we just can simply say if row is not 9, keep turning when you reach to the end. And if it is 9, then you do not need to do anything. So let's run this and see if this works. It moves all the way here. Then I expect here to turn left all the way. And I expect here to turn right. And turn right again. And so on. So till it get to this point, let me actually bring up another challenge for next session. So similar to what I already explained, that the robot wanted to go left, right, we want to modify this code that I share it with you guys. By the way, I put all of these codes in the my GitHub, and I share the link down below if you want to access. So we want to modify this code that I gave it to you with the like minimum modification in order to this robot be able to go bottom down, bottom down, bottom top, and so on, following basically this pattern that I showed you. So let's see who can do this by next session that I redo it myself. All right, the Astro. There we go. We reached to the end cell, and it's exactly follow the path that we wanted to path. So that's it for today. Thanks you guys for watching this video. If you have any comments, please leave it down below, and stay tuned for next sessions. Have a great day, everyone.